this tutorial we are going to develop our first hardware project, and we are going to use the GPIO pins of the Raspberry Pi and link up an LED. So basically this LED brought from the local vendor. These are 2 volt and 200 milliamps rated. So you must know the ratings of your LED for this project, and that will help you determine the resistor that you have to attach with the Pi. So the project is simple. You have to go to the chart describing the pin configuration of the 40 pins of the Raspberry Pi. Here I am going to use the GPIO 4 pin, which will give us the maximum voltage output of 3.3 volt. So that will drive the LED, and as it is 2 volt rated, so a maximum of 2 volt can be allowed across the LED. So the extra 1.3 volt will drop across the resistor. So this will help you determine the value of the resistor, because the rated current is 200 milliamps. So the current in this circuit cannot cross that. So the hardware you require for this project is a simple breadboard, jumper wires like this, and your Raspberry Pi with all the connections like keyboard, mouse, and a USB power adapter. So to make up the circuit, you first attach the plus 5 volt pin to the plus rail of the breadboard, and also attach the ground. Also you have to attach the ground of the Raspberry Pi to the negative rail of the breadboard. Now to use the GPIO 4 pin, you also have to attach the jumper wire from the 4 to a specific rail of the breadboard. Now to complete the current flow path, we have to connect the LED and the resistor in series with the GPIO 4 pin. Like the LED will have the positive and negative terminals. I am going to attach the positive terminal with the GPIO 4 pin, and the negative terminal will be grounded via the resistor which I am choosing here. The positive end of the LED is the long end which has the long strip in the LED. So you can connect the LED in the fashion like positive end will be connected to the GPIO 4 pin. Now for the value of the resistor, like the rated current is 200 milliamps, and the GPIO will give us 3.3 volts. So 1.3 by 200 milliamps will be an accurate resistor value, which is equal to 65 ohms. So you can use any resistor which has a value above 65 ohms. I am using a resistor of 220 ohms, but make sure the resistor value is not too high, then the current will be too low and the LED's brightness will go down. So using a 220 ohm gives us a fine result. So now that your circuit is complete, the current has a path to flow from the GPIO pin through the LED and resistor to the ground. So this is the complete hardware that you require. Now we will write a Python script in the GUI of the Raspberry Pi to make the LED blink. So to do that, again connect the Raspberry Pi with the display, the keyboard, monitor, and a LAN Ethernet cable, because you have to install some dependencies to work the GPIO library in the Python, and then just power up your Raspberry Pi by plugging in the power adapter. So this will again boot up your Raspberry Pi. Login using your login ID and password. Then you have to install some dependencies. You can do it from the LX terminal and also from the console. So to install the dependencies, just you have to get sudo apt-get install python def and python pip. As I have already installed them, I do not require them again. But this will take some time, so just make sure you install them. And after that, you have to import the RPi.GPIO library using the pip dependency. So the codes to do that are available with the Word file attached in this video. And after you do that, you have to run the Python script. So to do that, you have to create the Python script and run it. Make sure you run the Python script as a root user, because without the root user access, you will not be the GPIO you will not be able to write to the GPIO pins. So again, start the GUI using startx and create a Python script using the LX terminal at a suitable place. I am building it in home/py. To do that, just type nano led link. This is my file name .py. So here we will write the script to blink our LED. So at first we have to again import our library GPIO rpy.gpio. So make sure you type the library as mentioned here, because the library is case sensitive, and we also will require the time library of Python. Then we will set up the GPIO pins as the VCM connection. Here we have to remember that two sort of connections are possible with the GPIO pins. One is the VCM connection and another is the board connection. Depending on those, the number of the pins will be different. So I am using the VCM connection, which will make our fourth pin, which will make the pin I am using as the fourth pin, GPIO 4. So after we set up the connection, we need to get the output on the fourth pin. So to do that, and then we can write to the pin like now we have written a value 1 in the fourth GPIO pin, where 1 means the high value like 3.3 volt and 0 will mean 0 volt. Now if we execute the file, it should glow the LED up. So before executing it, just save the file and go to the root user mode. And typing sudo I. Then we can execute the LED blink script using now it cannot find the file because the ledblink.py is not in the root user mode. So we have to write it again in the root user mode. Make sure you do this, because without this we cannot write to the GPIO pin. So again, just import the library. Import the time library. The script ready, save it and again run it. Now you have the LED glowing in the harder. So now we are going to automate the process of blinking the LED so that it will glow bright and dark after a mentioned time interval, which will depend upon our Python script. So to do that, we will have to make a while loop, which is going to be an infinite one. So that will make the LED glow bright and dark after a mentioned time interval. So we are going to edit our previous script, and here we are going to take an input from the user, which will state the first
or initial state of the LED, i.e. that whether it will be dark or bright. So to do that, we have to define a variable x. That's that. And we have to make sure the input is binary, because we are only dealing with ones and zeros. So then we can create the while loop, which will be an infinite one. So the condition is always true. And then again, to make the indentation right in Python script, you have to hit tab every time after you write a script inside the while loop, because again Python is sensitive to indentations. So here we will write the, and we will make the LED retain its state for 6 seconds. Then the LED will change its output. And again it will retain its state for say 2 seconds. Now our script is ready, and we can just save it and run it from the console. Then it will ask for your binary input. Say if we are going to light up the LED as its initial state, then we are going to give the input as 1. So if we give the input as 1, so it will enter into the infinite while loop, and it will blow on and off after a few times. Like say it will remain on in for 3 seconds, and then it will go off for 2 seconds, and it will again be on for 3 seconds. Like this will continue for an infinite time, as the while loop was infinite. So to stop it, just enter Control and C from the console. So this will make the LED to retain its state. So if you want to just end the script there and make the GPIO pin free of its state, you have to write another command in the Python script to clean up the wiring settings that the hardware already has. So again, just edit the script and add GPIO.cleanup function at the end of the script while loop. This will make sure when the while loop ends, the GPIO pin is free of its state depicted by the Python script. So again, save the file and run it. So again, it will ask for the input. Let's make it 0 because it is initially on now. So if you press 0, then it will be off for 3 seconds. Then again it will glow for 2 seconds. Like this will continue. So now say if it when we will stop the while loop, the cleanup function will make the LED free from the pin that is depicted by the script. So we can make the while loop terminate when the LED is on, so that we can understand the function of the cleanup. So when the LED is on, if we press Ctrl C, and the script ends, but still the LED is on. This depicts the function of the GPIO.cleanup. So that's it for this video. Next time we will implement a traffic signal using 3 LEDs, which will use a green one, a red one, and